Bismillahirrahmanirrahim. Welcome to this lecture, which is speaking about the series. The last part we spoke about the sequences, and we say the sequence is a function whose domain is the positive integer. For the series, it is related to the sequence in a way that if we try to add the terms of an infinite sequence, we get an expression of the form a1 plus a2 plus a3 plus up to an goes to infinity. This is called infinite series. So we can define the series as sum of the terms of a sequence. We call it infinite series or just a series. And we denote it by the symbol sigma n from 1 to infinity of an. This notation means the sum of the terms of the sequence. So we can say that sequence, for example, if I have 2, 4, 6, 8, 10, this is sequence. And if we add these terms, 2 plus 4 plus 6 plus 8 plus 10 plus, we call this is a series. So the series is just the sum of the term of the infinite sequence. And as we did before for the sequence, in which that we spoke about the convergent, divergent of the sequence, also we can do the same thing for the series. The series sometimes can be convergent, sometimes it can be divergent. And to test whether the series is convergent or divergent, we need to speak about something called the partial sum. So if we are given a series, sigma, an, where n starts from 1 to infinity, or n starts from 0 to infinity, given by a1 plus a2 plus a3, then if we say that or denote Sn to be the partial sum, nth partial sum, and we mean that the Sn as the nth partial sum, it means we are adding the first n terms. So Sn is just sigma of the first n terms. Now this Sn will, or sub n will create a sequence. Now this sequence is sub n. If it is convergent, then the series is convergent, and it is divergent if it is divergent, then the series is divergent. If we find the limit for this sequence, limit of Sn, if it is equal to some given number s, so if the limit exists as a real number, then the series sigma an is called convergent series. And the sum of this series is equal to S. Now, if the sequence S sub n is divergent, then the series is called divergent series. To explain this with example, suppose that we have this series. And we need to show that this series sigma n equal to 1 to infinity of 1 over n times n plus 1 is convergent. And we need to find its sum. Let's see. To test the convergence of this series, we are going to find the partial sums. S1 is equal to. S1 means I'm going to replace n by 1. So it is 1 over 1 times 1 plus 1, which is equal to 1 over 2. This is now the first partial sum. S2, now replace n by 2, it will be 1 over 2 multiplied by 2 plus 1 is equal to 3, which is equal to, sorry, this is equal to, I should take the first two terms. Let me rewrite it again. This series 1 over n times n plus 1, if we expand it, it will be 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, this is n plus 1, plus 1 over 4 times 5, and keep going in this way. So the first partial sum, which is S1, is equal to the first term, 1 over 2. S2, the second partial sum, will be the sum of the first two terms. It is 1/2 plus 1 over 6. We add them together. This will give me 3 over 6, which is equal to 4 over 6. That is equal to 2 over 3. S3 is equal to the sum of the first three terms. So I will take the first three terms. So it is 1 over 2 plus 1 over 6 plus 1 over 12. This is 2 over 3 plus 1 over 12. The first two terms is just S2. So this is equal to 9 over 12. Or it is equal to 3 over 4. Similarly, find S5. So S4, not S5, S sub 4. That will be 3 over 4 plus the fifth term, which is 1 over 20. This will give me 16 over 20, or it is equal to 4 over 5. No, so the sequence Sn is given by the first one was 1/2, second term 2 over 3, third term is 3 over 4, and fifth term is 4 over 5. So from this, we can find the general term Sn. The first term is 1 over 2, 2 over 3, 3 over 4, 4 over 5. So Sn will be, it is n divided by n plus 1. This is the general term for this sequence. It is Sn equal to n divided by n plus 1. Now the limit for this Sn as n goes to infinity is equal to the limit of n divided by n plus 1 as n goes to infinity. And as we did for the continuous function, we can take the highest power. I will have limit of n divided by n as n goes to infinity, which is equal to 1. Which means, since the limit of Sn is equal to 1, it exists finite. It means that the series is convergent. It is convergent. And also the sum of the series, which is 1 over n times n plus 1, is equal to the limit of Sn as n goes to infinity. Is equal to 1. So the sum of the series is equal to 1. So this is the idea of finding series or check whether the given series is convergent or divergent. We need to find the partial sums, then find the limit of that sequence S sub n. If it is convergent, then the series is convergent, and the sum of the series is equal to the limit, which is equal to the sum. And if the limit of the sequence S sub n is divergent, then the series itself is divergent. In some cases, we can speak about special kind of sums or of the series. And we call this special kind geometric series. So the geometric series is just a series that can be written as A. The second term is A times R. So we are multiplying the first term by R. Now multiply the second term by R, I will have AR squared. Fourth term is AR to power 3. So in each step or in each term we multiply by R, a constant number. And this can be written as sigma of A, where A is the first term not equal to 0 times R to power n minus 1, where A is not equal to 0. This type of series is called geometric series. It is geometric series. And the geometric series is convergent if the absolute value of R is less than 1. Sometimes we call it the base of the series. If the base of the series is less than 1, or the absolute value is less than 1, then the sum is then the series is convergent, and the sum is equal to A divided by 1 minus R. If the absolute value of R is greater than or equal to 1, then the geometric series is divergent. For example, suppose that we have this series and we need to check whether it is convergent or divergent. The first term is 2 over 5. Second term, which is 4 over 25, is 2 over 20 over 5 multiplied by 2 over 5. So it is, the first one is A. So I can say this is A multiplied by 2 over 5. Third term, which is 8 over 125, is equal to 2 over 5 multiplied by 4 over 25. So it is A multiplied by 2 over 5 to power 2. We go for the third term, 16 over 20, 625. This is 2 over 5 multiplied by 8 over 125, which is equal to A times 2 over 5 to power 3. Means this series is geometric. So it can be written as sigma of 2 over 5 multiplied by 2 over 5 times n minus 1, where n start from 1 to infinity. You have to be careful about the start point. It is n equal to 1 to infinity. So we have A equal to 2 over 5. This is the first term there. And R is equal to 2 over 5, which is less than 1. Which means this geometric series is convergent because R is less than 1. So the sum is equal to, it is A divided by 1 minus R, which is equal to 2 over 5 divided by 1 minus 2 over 5. And the sum for this series will be equal to 2 over 3. So it is geometric series, and since R is less than 1, this series is convergent, and its sum is equal to A divided by 1 minus R, which is 2 over 5 divided by 1 minus 2 over 5, which is equal to 2 over 3. Another example. If we are given this series, I have a 3 to the power n plus 1, or sigma of 3 to the power n plus 1 multiplied by R to the power, or 4 to the power minus n. Let's see if we can write it as geometric series. This can be written as sigma of 3 multiplied by 3 to the power n. This n plus 1, I can write it as 3 multiplied by 3 to the power n. And 4 to the power minus n can be written as 1 over 4 to the power n. Or you can say the sigma of 3 multiplied by 3 over 4 to the power n. Where n starts from 1 to infinity. So the first term, if we just expand it, I will have 3 multiplied by 3 over 4 to the power n. Sorry, to the power 1 plus 3 multiplied by 3, 4 to the power 2 plus, so for the third term, it is a 3. That will be 3 over 4 to the power 3. So we can consider the first term as 9 over 4 plus 27 over 16 plus 2. This is 81 divided by 64. So we can see it is very clear that this is geometric series with A equal to 9 over 4 and R is equal to 3 over 4. So this is geometric series with A equal to 9 over 4 and R is equal to 3 over 4. And since R is less than 1, it means it is convergent. So the sigma of 3 to the power n plus 1 times 4 to the power minus n is equal to A divided by 1 minus R, which is equal to 9 over 4 divided by 1 minus 3 over 4. 9 over 4 divided by 1 minus 3 over 4. This is can be written as 9 over 4 divided by 4 minus 3 over 4. This will cancel this one, and 4 minus 3 is equal to 1. I will have 9 over 1, which is equal to 9. So this series is convergent. It is geometric series, and with R is less than 1. So it is convergent, and the sum for this series is equal to 9. So this is n start from 1 to infinity. So this is the idea of the series. Or to check whether the series is convergent or divergent. If it is geometric, we need to check the base or R. If it is less than 1, it is convergent. If R is greater than 1, it is divergent. And if the series is convergent, then we can find the sum of the series.